Assalamu alaikum. Welcome to my video series on data science. In the previous session, we discussed about the valuation metrics for classification and regression. In today's video, we are diving into the evaluation metrics for clustering, essential tools to understand how well your clustering algorithm performs. Common evaluation metrics used for clustering include Silbert coefficient, Davies-Bordelen index, Kalinski-Harabas index, within clustering sum of squares, and others. In this session, we will begin by discussing cohesion and separation, the foundation of many evaluation metrics, and then focus on one of the most popular methods, that is Silbert score. Now let's discuss the cohesion and separation. Cohesion measures how closely data points within a single cluster are grouped together. It evaluates the compactness of a cluster. Good clustering should have low cohesion values. Separation measures how distinct or well separated the clusters are from each other. It evaluates the distance between the clusters. Ideally, the clusters should be well separated from each other with high separation values. These two aspects are combined in Silbert score, which effectively balances both cohesion and separation. The Silbert score evaluates the quality of clustering by calculating a score for each data point based on this formula. Here A indicates cohesion, the average distance between a point to all other points in its own cluster, and B represents separation, the average distance between the point and all points in the nearest neighboring cluster. First we calculate the Silbert score for each data point, then for each cluster, and then for the complete clustering. To make it concrete, we will use an example dataset to explain how Silbert score works and how to interpret it. Here we have data that are results of a clustering process. We have 5 data points that are divided into two clusters, cluster 1 and cluster 2. For ease of computation, the first step is to calculate the distance matrix. Distance matrix contains the distance between each data point. So the diagonal has the value 0 and the values above diagonal indicate the distance of each data point with the other data point. First we will calculate A, which is cohesion for each data point. So the formula of cohesion is the average distance between a point and all other points in the same cluster. So point A is located in cluster 1, which contains further 3 points A, B and C. So we will calculate the distance of A with B, A with C, and then calculate the average distance. So the average distance is 2.12. Similarly, we will calculate the value of A for point B. We will take the average of distances of B with A and B with C. Similarly, we will repeat it for point C. For point D, we will calculate the distance with the other data point in the same cluster, which is E. Since there are only two values in this cluster, we don't need to take average. So now we have cohesion values for all data points. The next step is to compute the separation values, which is B. Separation is the average distance of a point with all other points in the different nearest cluster. To calculate the separation for point A, we will take the distance of A with D and A with E and take the average. We will get 9.93. Similarly, we will repeat the same process for each data point. For B, we will take the average of distance between B and D and B and E. For C, we will take the average distance of C and D and C and E. As point D is in second cluster, so we will take the average distance of this point with all other points in cluster 1, which are A, B and C. So we will take the distance of D with A, D with B and D with C, and we will take the average and we will get 7.81. Similarly, we will repeat this for point E and we will get 9.22. Now we have all of the values for separation as well. So we have A and B values. Now we can put this into the formula and calculate the Silbert score for each data point. So the formula for Silbert score is B minus A divided by the maximum of B and A. So for point A, the B value is 9.93 and the A value is 2.12. So we will subtract them and then divide with the maximum of them, which is 9.93, and we will get a score equals to 0.79. We will repeat this for all other data points in cluster 1 as well as in cluster 2. After completing this iteration, we have the silver score for each data point individually. Now we have to compute average silver score. And average silver score is calculated by summing up all of the silver score and then divide by the total number of data points. The average silver score is 0.80. Now let's learn how to interpret the silver score. A silver score close to 1 is excellent. It means the clusters are well defined with low overlap and good cohesion. If the scores are closer to 0, it would suggest that the clustering is of an average quality. Clusters are not well separated and they have some overlaps. And negative values indicate a significant issue with the clustering, such as misclassification points. To visualize this, we can plot the silver score for each point in a silvered plot, showing the distribution of scores within each cluster. Thicker bars indicate consistent cluster quality, while thinner or negative bars show potential problems. And that's how silver score helps you evaluate clustering. By combining cohesion and separation, it provides clear, quantitative measure of clustering performance. It's an essential tool for understanding and improving the unsupervised learning models. If you found this video helpful, don't forget to like, share and subscribe for more videos on data science and AI. See you next time.